Hello and welcome. In this video, we're going to look at how to solve for many different currents using the current divider equation. This circuit gave us 6 amps across the top, and it gave us every one of our resistor values, which means that we can use our current divider equation to solve for the branch currents of each of those. The first thing we need to do every time we're looking to use our current divider equation is solve for RT. RT is equal to, and we can solve out after we evaluate the circuit here. So let's go across the top where our total current starts. See, we hit a node. We go down to the next node. There's no resistance between those, so those two are actually the same node location, which means that we can go down this first branch, R1, and that's going to be in parallel with R2. And if we continue down, we see that there's no resistance along this top branch until we get down to here. And so that's going to be our another node here. And those are all in parallel so far since there's no resistance in between them. We'll see that we have R3. So it's a parallel of R3, R4 in parallel, and R5 in parallel. So we can plug all of those into our Desmos over here and say that we have 1 over 8 plus 1 over our R2, that's also 8, plus 1 over R3, that's 6, plus 1 over the next one, R4, that's 6, plus 1 over the last one, which is also 6, R5 there. And so we're given a total resistance, RT, of 1.33 ohms. We expect our total resistance to be smaller than the smallest resistor. Our smallest resistors were those 6 ohms, and so this makes sense for us. Okay, so now that we have our total resistance, we can use that in our current divider equation. We can say that it is what we have total, which is RT, divided by what we want. And so we're going to identify I1 to get to I3 first. So we want I1. So we'll say I1 is equal to, and what we have going through I1 is what the I1 current will divide through. And the I1 current is going to be delivered to both the R1 and R2 in parallel. So we're going to place our RT on top, and on bottom, we're going to place R1 in parallel with R2, right? And we can solve for that parallel first before we actually go after our total IT equation here. So let's do that. We'll send this out and we'll say that the parallel of R1 and R2 together, 1 over 8 plus 1 over 8, right? It's 4. That means that we could probably have used the other equation as well, where we say, well, we have two 8 ohm resistors, so 8 divided by 2 gives us 4 ohms. And that would be the same thing. So now we can rewrite this. We can say that it's not R1 in parallel with R2, it's actually just 4 ohms because we solved for that. We can plug in our IT and our RT there as well. So we'll say that we have 4 ohms. Our RT was 1.33 ohms. And the total current IT was given at 6 amps. So then we can multiply that out. So we'll send this here, and we'll say that we have 1.33 divided by 4 multiplied by 6, 1.995. So our I1 is equal to 1.995. We can even round that up. We can say I1 is actually equal to 2 amps. Right, so immediately we can identify what I2 is, because those are the two main branch split. We know that that node split right here, and 2 amps went down. And so the other, whatever's left in the circuit, has to go on, and that's going to be equal to I2. So we'll say that I2 is equal to 6 minus 2, which leaves us with 4 amps to go down through the remainder of this circuit on this side. So now we can identify I3. We can say I3 is equal to the division right here. And we know that R1 and R2 equal each other, so they're going to divide perfectly, which means that the I3 current and the current through the R1 resistor and the current through the R2 resistor are going to match each other. It's going to take our 2 amps and divide it perfectly. So we expect 1 amp for this R1 branch and 1 amp for this R2 branch. The rest of the circuit gets 4 amps over here. So I2 will divide 3 different directions equally. They're all 6 ohms over here, so we'll have our 4 amps divide out down each of these branches, and we can take our 4 amps and divide it by 3. 4 divided by 3. And that gives us 1.33 amps down this R3 branch, 1.33 amps down this R4 branch, and 1.33 amps down this R5 branch. And if we actually sum those together, like KCL states, we can actually get back to our total current resistance of 6 amps. So let's do that. Let's take each one of those small branch currents, the smallest ones down here, and sum them together. So we know that we had 1 amp down the R1 branch. We'll add that to 1 amp down the R2 branch. We'll add that to the 1.33 down the R3, 1.33 down the R4, and the 1.33 down the R5. And we're left with 5.99, and if we round that up, that's our 6 amps. We can also say that the I1 and I2 together are going to be the total current as well. So 2 plus 4 would give us that 6 amps also. Okay, let us know if you have any questions.